Hello everyone. Sorry I haven't uploaded lately. I've had some school stuff and I've been prepping for the USACO. But in doing that, I found this pretty interesting problem, which is problem 3 of the 2017 bronze contest. So, if you advanced in competitive programming, you can probably just click off because this might not be that much of a benefit, but if you're new here, this is a great problem, I think, in terms of learning how to problem solve. So let's get started. The basics of this problem are we're given a grid of counts of size n by n. So in this case, we're given a grid of size 3 by 3, right? And this represents Farmer John's cows. So what he's basically saying is, there's these teenagers who visit his farm and tip over the cows, right? So all of these ones, right? These ones are tipped over cows. And Farmer John wants to untip all of the cows, right? So he doesn't want any cows with the number 1, because 1 means the cow is tipped over. So he creates this machine called the Cow Untipinator 3000, which is a really awesome name. But basically what it does is he can choose a rectangle containing the top left cow, and he can flip all of the cows in that rectangle. So for instance, if he chooses this rectangle, all of the 1s become 0s, and all of the 0s become 1s, right? Because he flips every cow. Even if the cow is untipped, he'll tip it back over. But if the cow is tipped over, he'll untip it, right? So it's sort of just like flipping over the cow. And then the rectangle always has to contain the top left corner, right? So you can't choose a rectangle like these 4 ones, because that doesn't contain the top left cow. Interesting way the machine works. But let's take a look at the sample input. So we're given a 3 by 3 grid, and we can see that there's a lot of cows that are tipped over. But what it's saying is, we can first apply the machine to all of the cows, basically a rectangle containing the top left cow and the bottom right cow, and you'll see that all of the 1s become 0s, and all of the 0s become 1s. Furthermore, we'll apply this once more to these 2 cows, because that contains the top left cow. And in doing so, we convert these 1s to 0s, and now we have a field of 0 cows, which means we're done. Great. So, as you can see there, that entire thing took 2 uses of the machine. And we're basically asked to output the minimum number of times the machine needs to be applied in order to untip all of the cows. Alright, so now let's see how we're gonna tackle this problem. I'm gonna do a quick sketch so we get a feel for how the problem goes. So let's go here and let's just make up a random grid, right? So we're gonna say, that's terrible, we're gonna say n equals 4, and we're gonna just make a random grid. So let's say 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, and then 1, 1, 0, 1. Okay? So this is a random field, and then this is the top left cow. So we number that all rectangles that we tip over have to include this top left cow. Alright, so let's think about some unnecessary details that we can eliminate from this problem. If we think a little bit about this, let's just select a random rectangle, right? Let's select this rectangle, just for an example, right? So we can see here that we have some cows that are not tipped over and some cows that are. What if we flip this rectangle, right? If we flip that rectangle, we'll get 1, 1, 1, 0, 1, 0, 1, 0, right? We're just gonna flip all of the 1s to 0s and 0s into 1s. Alright, so my question here is, will we ever have the need to do this operation, but then to do it again, right? Will we ever need to apply a rectangle on a flip, and then have to apply the same rectangle flip in the future? Well, if you think about it for a second, well, not really, right? Because if we flip this again, we're basically just undoing what we did before, right? We basically did 2 flips and we got nowhere. And since the problem asks for the problem asks for the minimum number of times he needs to apply the machine, you can see that this is unnecessary. We never need to reconsider our flips, right? We either flip this section or we don't. We're never going to flip it twice or 3 times or 4 times or any number of times. We only need to flip it once or 0 times. And that kind of reminds me of something, right? That kind of sounds like a greedy algorithm. A greedy algorithm is where you never reconsider your choices. You make the best choice in the given scenario, and you just continue. You're never going to backtrack or reconsider what you've done. And then this is exactly a greedy algorithm, because we're never going to have to reconsider whether or not we made the right choice, because we're always going to make the right choice. So, with that out of the way, let's think about how we're going to tackle this problem. Alright, so we need to think about a method of approach here. How are we going to start looking at this grid? I say we want to start from the bottom right. Now, why is that? Well, let's think about all of the rectangles that we can choose, right? So, like, we can choose this one, we can choose, like, this one, right? There's only a single rectangle that includes the bottom right cow, right? There's this one. Any other rectangle will not include the bottom right cow. This rectangle, even though it includes a lot of cows, it misses the bottom right one. Same goes for a rectangle like this, right? There's only this rectangle that will include the bottom right cow. So we only get this single chance to reverse this bottom right cow, right? So if we see that the bottom right cow is a 1, we know for certain that we have to apply this rectangle as one of our operations. Because otherwise, this cow is never going to be flipped over, right? So now we know that we have to flip these cows over. So let's think about what we do after that. Well, let's look at this cow, right? Once we flip this cow over, right, we decide whether or not we want to flip this cow over, we can take a look at this cow. Now, again, there's no other rectangle that contains this cow other than this one or this one, right? And since we've already looked at the large rectangle, there's only this single possibility that we can look at, right? So there's only this one chance that we get in order to flip this cow over, right? So I think you might be able to see where this is going. Every single time we look at a cow, we only get one chance to decide whether or not we want to flip that cow over. So if the cow is a 1, obviously we need to apply the operation, right? Because in the future, we're never going to have the chance to flip that cow over again. So, how are we going to approach this? I say we want to start from here, and we just basically go row by row, right? We go this way, we look through all of these cows, we look through all of these cows, we look through all of these cows, and then finally we look to the beginning. Now, you might be thinking, why didn't we start from this corner? Well, the problem here is, let's say, for instance, this was not a 0, but this cow was a 1. Now, if that cow was a 1, and we flipped it into a 0, later on, we might actually get a rectangle which flips that cow back into a 1, right? If we just go in this order, we might end up just undoing all of our work, right? We're gonna get a solution, but it's not gonna be the minimum because we have some unnecessary operations that we have to do. So I think we just start from here, and we go back, and we go back, and we go back, because this means, like I said before, there's only one chance we get to flip every single cow, which means that all of our options, all of our decisions, are gonna be right. We're never gonna make a wrong decision, because our decisions are always gonna be right? We only get one chance to flip over a cow, we either do or we don't. So I think we can actually use some DP here by starting from here, and we're gonna use push DP. So we're gonna push the result of this onto every single other cow, right? Well, if this cow is flipped over, let's think about this. So let's define a vector of vectors real quick, right? So we're gonna make basically a field like this, where all of the cows are zeros, right? And what we're gonna say is, let's say we need to flip this rectangle, right? If we want to flip this rectangle, we're just gonna add 1 to all of these cows, right? So we're gonna plus 1, plus 1, plus 1, all the way down to the end, right? So we're gonna add 1 to every single cow. And what this is keeping track of is the number of flips, right? This is the number of flips. So let's say we need to flip this one over, right? If we need to flip this cow over, we're gonna add 1 to the entire rectangle, right? We're gonna add 1 to this rectangle. For each of these elements, we're gonna add 1. And then we're just gonna continue, right? We're gonna add 1, add 1, add 1, and at the very end, we just need to look at this element, right? If we look at this element, it's gonna be the combined number of flips that we need to do, right? It's gonna be the total number of flips that we need to do in order to flip all the cows over, because this cow is gonna be flipped over many times. It's gonna be flipped over the exact number of times that we flipped over the rectangles, right? It's going to be the number of rectangles that we had to use to flip the cows over. So this is sort of just like push DP, right? We're pushing the outcome of every single cow into the rest of the cows. And we're just looking at this one. So now that we have an approach for the problem, let's implement this in code. I'm just going to call this solution.c++, right? And let's see. We need to... Alright, so we're going to get a file called caltip.n and a file called caltip.out. So I'm using C++ for this, but you can use any other language. I'm going to include cstdio, which is for reading files, and then basically iostream for input and output, and then we're also going to need vectors to organize our data. So take a main function, and then I'm going to do sdios sync with stdio. And if you don't know what this does, these two lines basically make it so that IO is faster, right? I'm not sure why, but basically it just makes you reading and writing faster, and it sometimes helps. I've had a lot of solutions where not including these lines actually made the solution time out. So let's see, we're gonna open the file of caltip.n in read mode, and then stdin. We're gonna need caltip.out in write mode as stdout. Alright, so we first off need to get n, which is the size of the grid. So int n stdcn n. And then we're gonna make a vector of vectors of int. And it's gonna be cows, and it's gonna be of size n, and then it's gonna contain vectors of size n. Nice. And then now we need to do a 2D array. So a nested for loop is a great way to do this. For int I equals 0, I is less than n, plus plus I. For int j equals 0, j is less than n, plus plus j. We're gonna say call c, right? And I'm using characters for this because if we just took in an input as an integer, it's gonna take in like 1, 111, 111. So I'm gonna actually take in the inputs one character at a time, so we only get these single characters. So we're gonna get a character, we're gonna c into character, and then we're gonna say cows of index ij equals, if c equals 0, we're going to set it to 0, otherwise we're going to make it 1. Alright, so now we got all of our input. And then we're going to implement what we said back here. We're going to implement this grid thingy that's going to keep track of however many flips that we need to do. So we're going to make another SV vector. I'm just going to copy this one up here. And this is going to be called, let's just call it dp. So for int I equals n minus 1, because what we're going to do is we're going to go backwards, right? Again, we discussed earlier why we didn't want to go forwards, because forwards is bad. We want to go from the bottom right to the top left. So we're going to go from n minus 1, I is greater than or equal to 0, and this is how you do a reverse list, by the way. You basically start from n minus 1, and then you go until I is greater than or equal to 0. And then you subtract from I each iteration. And then for int j equals n minus 1, j is greater than or equal to 0, minus j. So we can get the state of the cow right here, right? We can see what the cow is like at this index I comma j, right? But we have a problem here, right? We have a problem as in, if we look at this 0, right? That's a 0, which means the cow is not flipped over. But if we have to flip over all of the cows from this 1, right? If we have to flip over this entire rectangle, then that means this cow isn't actually a 0. That cow is a fake 0. That cow is actually a 1, right? Because earlier we had to flip over this cow, which in turn made this cow a 1. So how do we know the real state of the cow? Well, we can look at our flips, right? We can look at the number of flips that we do. If the number of flips for that cow is an odd number, right? If it's an odd number, then that means that that cow is actually the opposite of what it's saying, right? If it got flipped 1 time, or 3 times, or 5 times, that cow is now the opposite, right? Instead of a 0, it's a 1, and instead of a 1, it's a 0. So we can actually just test whether or not the cow's current state is equal to the evenness or the oddness of the number of flips it has. So what we're going to do is we're going to say, if the dp of ij modulo 2 is equal to cows of ij. I'm sorry, not equal to. And this is basically just like simplifying all of what we said down to one line, right? So if the number is odd, right? If this is 1 and cows of ij is 0, that means cows of ij is actually 1, so we should flip it. And on the other hand, if this is 0, if it's an even number, and cows ij is 1, then we know that cows of ij is a true state, right? It's actually tipped over, and we need to tip it back over, right? So we can do that, and then we can say so we want to flip over the cow now, right? We know that we want to flip over the cow, but we also need to flip over every single other cow, right? We need to flip over this one, and this one, and this one, all the ones in that rectangle. So we're going to have a nested loop inside of a nested loop. So for int k equals 0, k is less than or equal to I, because again, we want to include the cow that we're looking at. Plus k for int L equals 0, L is less than or equal to j, plus L, we're going to increment dp of index kl. And what this is doing is it's basically just going through this entire grid, and it's saying that, oh, this one needs to be flipped over, this one needs to be flipped over, this one needs to be flipped over. It's just adding 1 to all of these elements. And then we're actually done now. As we said before, all we need to do is look at the first cow, the top left cow, because that cow is being flipped the number of rectangles, right? It's going to be flipped the exact same number of times as there are rectangles. So we just need a stdc out dp of index 0, 0, and then std end l. And that's our solution. So we can really quickly see if this works. I'm just going to comment out the files because we want to go from terminal stdn. Let's just wait for this to compile. And then let's take this. And as you can see, it prints out 2, and the expected output is 2. Great. So I've already submitted this actually, so I'm not going to submit it right now. But this, in fact, does work. And this is the reason why. So I hope you guys enjoyed this video. This is a really interesting problem. So I just wanted to share it with you guys. And I'll see you in the next video. Thanks for watching.